Hello, my Calc 2 student. Today we talk about power series. This is section 9.9.8 from your book. But before we start, I give you definition. Series, when you can write like a n's times x to the power n, whereas n change from 0 to infinity, call power series. If you have series when you have a n x minus c to the power n, and from 0 to infinity, this series we call power series with center. Sorry. Okay, with center at C. Okay, because we have series, first question about convergence. And this we have very important theorem. It tells us for power series, c to the power n, and from 0 to infinity, true one of following situation. First, series converges only at x equal c. This means series converges only if each term is equal 0. Second one, exists a real number r, positive, such as series converges for all x if x minus c less than r, and diverges if x minus c greater than r. And third one, series converges for all x. Okay, here we have couple of definition. First, the number r from this theorem we call radius convergence. Set all x for which series converges, call interval convergence. Converges call interval convergence. Now looking for a couple of examples. Example first, we have series, power series, n factorial x to the power n, whereas n change from 0 to infinity. Use ratio test. We have a limit n approach to infinity, n plus first term over n terms, absolute value. This limit we need found, okay? And it will be limit n approach to infinity, n plus 1 factorial x to the power n plus 1, and factorial x to the power n. Okay, simplify. We have cancel it. Here is factorial and n factorial cancelled. Okay, this means we have, because it's only x, it's not depend n, we can take it out of our limit, and we have limit n approach to infinity from n plus 1. But this limit is infinity for any x except 0. This means our series is diverges for any x except 0 and converges only x equals 0. Sorry, here's was this line before I start writing, and this means is x is equal 0. Okay, the next example. Let's go. Our series is 3 times x minus 2 to the power n. Here is n from 0 to infinity. Use same ratio test. You have limit 3x minus 2 power n plus 1 over 3 times x minus 2 power n. Don't forget about absolute value and approach to infinity. Start simplifying. We have 3 cancel it. Here is n. This is n cancel it. And this means this limit is limit x minus 2 absolute value, whereas n approach to infinity. Because function is not depend n, we have exactly absolute value x minus 2. And if you remember your ratio test, I hope you remember, this limit need be less than 1. Okay, this means radius convergence here is 1. What about the interval? It means x minus 2 stay between negative 1 and 1, x stay between 1 and 3. This means interval convergence is 1 to 3. Radius convergence 1, interval convergence 1 to 3. Great. Now looking at last right now. Our example number 3, we have series negative 1 to the power n, x to the odd power to n plus 1 over 2n plus 1 factorial, and change from 0 to infinity. Use same ratio test. You can write limit n approach to infinity absolute value. Because it's absolute value, this is factor, whereas negative 1 some power we skip, and here we have x to the power twice n plus 1 divide by twice n plus 1 and all this factorial. Divide by an, this means multiplied by flipping fraction, we have 2n plus 1 factorial over x to the power 2n plus 1. Well, a little bit simplified because we before we start canceling and approach to infinity. Finally, power x is 2n plus 2 plus 1, that means plus 3. And here we have 2n plus 3 factorial, 2n plus 1, x 2n plus 1. If I'm start simplifying, this is gonna get out. 2n plus 3 minus 2n plus 1, it's, you have 2 here. And what about factorial? 2n plus 1, next numbers will be 2n plus 2, 2n plus 3. This means here cancel it. And then you have 2n plus 2, 2n plus 3. Okay. Continue. And we have limit. This is x squared. We can take it x squared out. I'm not write absolute value because x squared is always positive. And approach to infinity. 1 over 2n plus 2 times 2n plus 3. This limit is equal 0. 0 times x squared is 0. It's a less 1. This means this series is converges for all x. It means radius convergence is here is infinity, and interval convergence negative infinity to positive infinity. Okay. Great. Now we have how we use power series in the future. We talk about function we defined like power series and looking some property. And here we have very important theorem. It tells us if your function fx defined like power series an x minus c to the power n and start with 0 to infinity has radius convergence R and interval convergence C minus R C plus R, then first we can define derivative and antiderivative this function. Derivative will be, we take derivative for each part, it means n a n x minus c to the power n minus 1, whereas n changing from 1 to infinity, and antiderivative, this means undefined integral from our function. It will be some constant. I write different way. You can see it's different. See what we have inside. Plus an x minus c to the power n plus 1 over n plus 1, whereas n start with 0 to infinity. Okay, but we have more information. And radius convergence. For both of this function, derivative and antiderivative, equal R. This means same like its function. And interval convergence is same, maybe except endpoints. Okay. You see how important this theorem? This means if you know about function interval convergence, this means you have same information about derivative and antiderivative. Okay. Looking some example. Let's go our function fx is x to the power n over n, whereas n from 1 to infinity. First, we can easily found derivative this function f prime x. It will be series n x n minus 1 over n, and from 1 to infinity. Here is n and n cancel it, and you have derivative is x to the power n minus 1, and from 1 to infinity. And integral antiderivative for this function dx, it will be series for integral x to the n over n dx, because operation integration is linear, and this is give us series x n plus 1 over n times n plus 1, and start with 1 to infinity and plus some constant c. Okay, now question: can we found radius convergency and interval convergency for this three function? Okay, we're first doing for function fx. Okay, for fx we have limit x n plus 1 terms over n plus 1 times n over x n, and approach to infinity, and here we have absolute value. Simplify if you have then and then, and oops, you have absolute value x time limit n over n plus 1. Oh, this limit we're solving a couple of times. This limit is equal 1. This means here we have absolute value x. It need be less than 1. Okay, great. If you have absolute value x less than 1, this means radius convergence is 1. Interval is possible -1 to 1, but question about endpoint. Okay, great. Let's x equal -1. We have series -1 to the power n over n, and from 1 to infinity. This is alternating harmonic series, and how you remember, it's converges. Let's x equal 1. You have, if you plug, you have 1 over n, and from 1 to infinity, but this is harmonic series and diverges. Finally, we have radius convergence equal 1, but interval convergence is -1 include, 1 not. What about derivative of our function? We have radius convergence is equal 1. How you remember derivative is x to the power n minus 1, and start with 1 to infinity. You can easily see it's a geometric series, because the series is 1 plus x squared plus and continue. It converges only if absolute value x strong less than 1. This means interval convergence. It will be -1, 1, open interval. This means difference between function and derivative. For function, -1 include for interval convergence. for derivative? No. Okay. Looking what happened with our integral antiderivative function. How you remember for our theorem r equal 1, we have interval -1 and 1, and we need checking endpoint. Okay, here we have series. This is equal series n from 1 to infinity x to the power n plus 1 over n times n plus 1. Let's x equal 1. We have series 1 over n times n plus 1 and from 1 to infinity. This series is converges because limit comparison test, you can use series 1 over n square with p series with p equal to greater than 1 converges. And what does give us limit comparison test? A limit n approach to infinity 1 over n squared divided by 1 over n plus 1. It gives us limit n plus 1 over n squared this is equal 1. This means p series is converges, our series is converges. Okay. What happened if we plug in x equal -1? You have series -1 to the power n plus 1 over n times n plus 1. This is alternating series, and alternating series is converges absolutely because series which take it absolute value for each term, it will be series. Oh, wait, minus, sorry, automatically. It will be series 1 over n times n plus 1. We know this series is converges. Okay, this means for antiderivative you have r equal 1 and interval convergency is closed interval -1 to 1. Okay. Now doing couple of examples from your book. It's help you found solving homework. Okay, number 8. Here we have series. This we need found radius convergency, and series is will be -1 to the power n x to the power n over 5 to the power n, and from 0 to infinity. Okay, use ratio test. We have limit x n plus 1 5 n plus 1 power. Here is 5n x to the n and approach to infinity. Start simplifying. You have here get, and this is 5 and this one, and finally we have this limit is absolute value x over 5. Because absolute value x over 5 need be less than 1, this means absolute value x need be less than 5, and radius convergency here is 5. Next question. Question number 26. here we need found interval convergence. Okay, and this we have series -1 to the power n x to the power 2n plus 1 over 2n plus 1, and from 0 to infinity. Okay. Use same ratio test. You have limit x twice n plus 1 plus 1. Okay, how I'm counting? This means n plus 1 terms, whereas you n substitute n plus 1. Where you have n, you plug in n plus 1. It's it. Twice n plus 1 plus 1. And n term is exactly term what you have in your formula. But we need divide. This means we flip our fraction. Okay, and approach to infinity. Here we a little bit simplify. A limit and approach to infinity. What we have here? X power 2n plus 3 over 2n plus 3 times 2n plus 1 over 2n plus 1. Okay, what we have here? This is cancelled, and here we have square, and this means our limit will be x square out, limit 2n plus 1 over 2n plus 3. This limit is equal 1. This means here I have x square. X square less than 1. This means absolute value x less than 1. Radius convergence equal 1. X stay between -1 and 1. Okay, this means our interval convergence -1 and 1. Checking our endpoint. What we have here? Let's go x equal 1. X equal 1. What I have? I have series -1 power n, 1 any power, it's 1, over 2n plus 1, and from 0 to infinity. I have alternating series, and checking convergence alternating series, we have theorem. We have two criteria. First, an a limit an and approach to infinity need be equal 0, and second, next term need be less than term before, less or equal. Okay. Here we have limit 1 over 2n plus 1 and approach to infinity. 1 over infinity, classically 0. 1 over twice n plus 1 plus 1 need be less than 1 over 2n plus 1. 2n plus 3 less than 1 over 2n plus 1. It's true because 1 you divide for bigger number, because 2n plus 3 need be greater than the 2n plus 1. It means 2 greater than 0. Both of criteria work. This means this series is converges. Okay. Let's go x equal -1. What you have here? We have series -1 to the n, -1 to the 2n plus 1. Okay. over 2n plus 1, and from 0 to infinity. -1, second factor, this factor, it means -1 to the odd power, but this mean is always equal -1. This means my series now is minus series -1 to the power n to n plus 1. Okay? But this is alternating series when we study right now, and we know this is convergence. Okay? Finally, what we have? Radius convergency equal 1, interval convergency -1, 1, both of endpoint include. Okay. Doing one more example, example 38. Here we have series -1 power n plus 1 x minus c to the power n over n c to the power n. Here is n start with 1 to infinity. Okay. Trifound radius, trifound interval convergency. We have limit and approach to infinity, absolute value x minus c power n plus 1 plus 1 times n c to the power n and x minus c to the power n. Okay, start simplifying what we have. Here is done, this is done, it's done, here is done, and I have absolute value x minus c over c. This is not depend, and limit n over n plus 1. And this limit is equal 1. This means finally we have absolute value x minus c over c. Okay, great. X minus c over c less than 1. This means x minus c need be less, absolute value x minus c need be less absolute value c. This means radius convergency is absolute value c. Interval convergency, here it will be between minus absolute value c and absolute value c. It means x stay between c minus absolute value c and c plus absolute value c. Okay. And depend if c is positive, you have interval convergence is 0 to c. If c negative, you have to c 0. And I think you can easy checking endpoint and tell me what happened with endpoint 2. Okay, I'm trying to save time for show you one more example. That's example 48. Here we have function fx and define like series minus 1 n plus 1 power x minus 2 to the power n over n and start with 1 to infinity. And here we need found interval convergence for question A for function fx, question B for first derivative, C for second derivative, BCD for antiderivative. Okay. We'll first start with question A. Here we have limit approach to infinity, absolute value x minus 2 power n plus 1 over plus 1 and x minus 2 power n. Because we're doing it a couple of times, I think you can write as like absolute value x minus 2. Radius convergence it will be 1. Interval x minus 2 between negative 1 and 1, x between 1 and 3. And now we checking what happened to its endpoint. Let's go. X equal 1. You have series negative 1 power n plus 1. Then you have negative 1 power n, and all of them divide by n, and from 1 to infinity. Okay, counting what happened to it here. Here is negative 1. Okay, maybe I write one more time. Negative 1 power 2n plus 1 over n, and from 1 to infinity. But 2n plus 1 is odd number. This means negative 1. Any odd power, it will be always negative 1. This means minus 1 over n. Harmonic series diverges. What happened if x is negative 1? X is negative. Oh, sorry. What is negative? It's 3. We don't have endpoint negative 1. I'm only skip. X is 3. This means you have series plugging x equal 3 for your function. You have negative 1 power n plus 1. 3 minus 2 is 1. Any power is 1. n, and from 1 to infinity. And here is converges like alternating harmonic series. And this means finally answer R equal 1. Interval convergence is 1, 2, 3. 3 include. Question B. Here we have derivative your function, which give us start with 1 to infinity, negative 1 n plus 1. Take a derivative, you have n x minus 2 power n minus 1 over n. And cancel it, and you have negative 1 n plus 1 times x minus 2 power n minus 1. And start with 1 to infinity. What we have here? We have radius convergence is 1. Interval convergence, we always write as open interval minus 1 and 1, and try checking endpoint. But if you plug in endpoint, you have x equal negative 1. You have series negative 1 power. What I'm doing? Sorry. How I switch my interval. Interval here is from 1 to 3, I plugging 1, and then I have negative 1 n plus 1 times negative 1 n minus 1. This means negative 1 n power. And this is diverges. Same, if you plug in x equal 3, you have negative 1 n plus 1 power. It will be diverges. This means for derivative r equal 1, interval convergency is open interval 1, 3. C. What happened if you have second derivative? Okay. Second derivative, your function x, it will be minus 1 n plus 1. Here we have n minus 1, x minus 2, but power now is n minus 2. And here is n start with 2 to infinity. Okay. Radius convergency is same, 1. Interval convergency 1, 3. And I think if you easy check, you have 4. Now let's go x equal 1. You have series negative 1 n plus 1 n minus 1, and here you have negative 1 n minus 2. Okay, alternate. I'm not sure about alternating. Okay, 2n negative 1 power 2n minus 1. Okay, 2n minus 1 times n minus 1. And from 2 to infinity, and from 2 to infinity. But it's always negative. This means here we have minus series n minus 1. And term test show us a limit n minus 1. It will be infinity. It diverges. Same situation if you plug in 3. This means here we have r equal 1, interval convergence 1 to 3. And our last question, D. Integral from fx dx will be sum integral negative 1 to the power n plus 1 x minus 2 power n over n dx, and from 1 to infinity. Here you have some constant c, that is no big deal, plus series negative 1 to the power n plus 1 x minus 2 to the power n plus 1 and n plus 1. Start with 1 to infinity. And if you're looking for this series, r equal 1, we have same 1 to 3, and we checking, and we have x equal 1. You have series minus 1 power n plus 1 minus 1 power n plus 1 over n times n plus 1, and start with 1 to infinity. And this is exactly series 1 over n times n plus 1. I think we studied this kind of series, and this will be convergence. Use limit comparison test and p series 1 over n square. if x equal 3, you have series minus 1 n plus 1 n times n plus 1, and from 1 to infinity is converges. This means here we have series which converges for closed interval 1 and 3. And we're solving our problem what I'm planning. Okay.